For this episode, we are going to use slots of 3 and 4 on the first 4 bits for the jump instruction. Slot 3 is for the jump register instruction, which is to jump to the memory address where contained inside of the register B. In step 4, the stepper will enable register B to flow its address data to the program counter, and in the next instruction cycle, the stepper will start to execute code from that location. In step 5, the stepper will trigger the reset of the stepper so it can skip steps 5 and 6 so the CPU will run faster. Here is the modification of the stepper. When the reset is 1, it will immediately reset the whole thing. Let's look at how this jump works. First, we store the 05 data to register 0, and we jump to the memory address where contained in register 0. The stepper at step 4 will enable the register 0 and load its data into the program counter. You can observe that now it jumps to the 5th location in RAM. Another method to jump memory location is by using the data byte of the next byte in RAM. It is similar to the insert data byte method. And this method uses the slot of 4 for the first 4 bits. In step 4, the stepper will enable the program counter to set the memory address registered to execute the code of the data byte. Next, in step 5 the stepper will enable the RAM and set the data byte to the program counter. Hence for the next instruction cycle, it will load from that memory location in RAM. Here is the demo part for this jump data bytes instruction code, and we are at the end of the video. I will see you guys soon, bye.